Hey everybody, let's dive back into Houdini. Now we're only going to look at one new node today, but it's a really powerful and useful node. So let's start with some sort of shape. Let's say like a box here. We'll dive inside the box, so we're at the geometry level, and then we're going to just look at the copy and transform node. And copy and transform makes a certain number of copies, in this case 2 copies, of whatever geometry is fed into it, but it transforms them either spatially or rotationally or in terms of scale. So let's say, for instance, our translation is 1.5 meters to the right. Right? Copy has made a copy of our box, 1.5 meters to the right of our original. There's our original, there's our copy. And of course we can make more copies, and each copy will be transformed by whatever the translation we specify is. So let's do 20 copies, and now we can see we have a row of 20 blocks, each one 1.5 meters to the right of the previous. And this of course works for scale. Each block is 90% the size of the previous, and this works for rotation. Each block is 10 degrees rotated from the previous. And the copy object can then be copied again with a new copy object. So we can say copy and transform, and we can take this entire output of our first copy and say make 5 copies of it, translating each one up by a meter. And now we've got this result. And we could of course rotate each one of these copies, and so on. And through the use of this, you can create a very, very wide range of different structures. Take some time and play around with these values and see what kind of forms you can come up with by manipulating them. It's really a great tool for achieving interesting results from simple starting conditions. So let's look at an application of this. We'll start with a sphere, dive inside of the sphere. It's a polygon mesh. We're going to crank up the resolution, and let's make an opening into the sphere so that we can see inside. So we'll create a group node, match the name of the group to the name of the node by using $O_S, and we can keep binormals and select just the front of the sphere. Now immediately we see that we have a potential problem here. You might like the fact that this opening into our sphere is blocky. That might look interesting to you. We can take a delete node and just delete this group, and that looks quite cool. But how would you get this edge to be smooth? Well, if we look at the top of the sphere, we see that because of the way the polygons are arranged, we do have smooth circles at the top of the sphere. So if we just take our sphere and rotate it by 90 degrees on the x-axis, now we have a nice clean opening. Why? Because I've taken what was the top of the sphere and rotated it to the side. And you can actually work with any variation on this that you like. You can get really interesting, different holes into the sphere by using different rotations. But I'll rotate it to get a smooth opening, and with a poly extrude, like so. And whenever you're using the poly extrude, you're almost always going to want to output a back so that your extruded shape actually has a front and a back. And that light purple will be a guide to you that you haven't actually output a back. Sometimes it's hard to tell, but you output a back. And let's make some shelves or some floors inside of this sphere. So we'll bring in a box, merge it with our hollowed out sphere, and we'll make the height of our box quite small so it becomes like a floor. And now we can copy and transform and decide how many of these floors that we want. We can say we want, for instance, 3 floors above the center, so translating up by a certain amount. There we go, 3 floors above the center, and we can also say that we want 4 floors below the center, for instance. Again, by copy and transforming the floors down, let's say 4 of them, negative 0.11, and there we go. We have nice floors in our sphere. Now, of course, there's also sticking out the sides of our sphere, and that's where we can start to work with groups and deletes to contain those just within the sphere if we want to. First of all, let's take this box and give it some additional axis divisions so that it has some resolution that we can cut on. And then hold down Y if I want to cut a connection. And I'll call this group $OS and keep my group in bounding regions, a bounding sphere. So you can see if I delete the selection, if I delete the group, I'm actually deleting the opposite of what I want to delete. If I put my merge node back in here, right, I have my floors sticking outside of my sphere, but no floors inside. Well, there's a very nice, simple function where you can just invert a group using an exclamation mark. Exclamation mark in computing means not. So rather than group 2, deleting group 2, I want to delete not group 2. In other words, I want to delete everything that's not a part of group 2. And we see now my floors are confined inside of my sphere. And that's a great start, but of course we want to refine this a little bit. So we can, for instance, transform our floors so that they're sitting back a bit further. That'll make our front edge work better. And then we can enlarge the sphere a little bit so that these ragged edges here of the floors get covered by the thickness of our sphere. So we go into the group here and just say that we want the sphere to be a little bit larger. We can see we've got none of the floors sticking out, but we've also got nice, smooth edges inside. Even though the delete is creating ragged edges, it doesn't matter. The ragged edges are trapped inside the thickness of our sphere. And of course, you could go on from here and scatter points and use mountains and do any type of distortion or addition that you wanted to this shape. These tutorials are intentionally simple tutorials, not so that you will use the techniques in this way in your own work, but so that you'll learn the nodes and techniques and be able to create any shape, any kind of form that you can imagine.